In this topic, we are going to look at word problems that involve quadratic equations. Now, to tackle these problems, it's crucial to understand how the quantities in the problem relate to each other. And then the key step is forming an equation that models those relationships. Let's start by talking about a basic strategy for solving such word problems. The first step in solving word problems is to wrap your head around all the information given in the problem. List every quantity described in the problem, and definitely draw a diagram if possible. Any unknown quantities should be given a variable name like x. Step 2. Consider the relationships between the quantities in the problem. For instance, if you have a rectangle, look at the length and the width. How do they relate to each other? How does one quantity change as the others change? Form expressions that describe how the various parts of the problem relate. And then the key step is you want to write a single equation that contains only one unknown quantity that you're looking for. Finally, step 3, solve the equation. In these particular examples, our equations will be quadratic equations. So we want to use either factoring, completing the square, or the quadratic formula to get our solutions. Once we obtain our solutions, make sure they are feasible. Cross out anything that cannot be used. For example, a negative width for a rectangle just wouldn't make sense. Let's get started and let's look at several examples of applications of quadratic equations. Our first example. The length of a rectangle is 2 inches longer than 3 times the width of the rectangle. If the area of the rectangle is 56 square inches, what are the dimensions, length, and width of the rectangle? Now, if our problem involves geometry, I always like to draw a diagram to begin with. So, I'm going to draw a rectangle, and I'm going to label sides with an unknown. Now, we are told that the length of the rectangle is 2 inches longer than 3 times the width. So, I don't know the width or the length, but if I let the width be x, the width of my rectangle be x, then the length of this rectangle is 2 inches longer than 3 times the width. How do I write that? 2 inches longer means plus 2. 3 times, well, 3 times is 3 times. So, if I wanted to express 2 inches longer than 3 times the width, I would write the expression 2 inches longer than 3 times the width, or 3x plus 2. So for this particular problem, my width is going to be represented by the variable x, and the length is going to be represented by the expression 3x plus 2. All right, now that we have our unknowns identified, we have to go about writing an equation for this problem. We are told that the area of the rectangle is 56 square inches. Area is 56 square inches. Now, what do we know about the area of a rectangle? Well, I'm going to write off to the side here the formula for area. I know that the area of a rectangle is equivalent to taking the length times the width of the rectangle, right? That's the formula for the area of a rectangle. Length times the width. Now for our particular rectangle, our length is 3x plus 2 and our width is x. And so we can use this formula here to write an equation. The area of the rectangle is 56 square inches. The length of our particular rectangle is 3x plus 2. And our width is x. This is our equation that we can use to solve this problem. Let's make it look nice. On the right side, I have 3x plus 2 times x. So that is equivalent to the following: x times 3x plus 2 and equals 56. So let's put our number on the right side, because generally we like to solve equations where the variables are on the left. Now let's solve this quadratic equation. What's our first step? Our first step is to get rid of the parentheses by using the distributive property. So we are going to distribute x through to the left-hand side. I have x times 3x, which is 3x squared, x times 2, which is plus 2x. And while I'm at it, I'm going to bring that 56 over to the left-hand side from the right-hand side by subtracting it. So that's going to simply give me the quadratic equation 3x squared plus 2x minus 56 equals 0. How do we want to solve this quadratic equation? Well, you can choose. You can complete the square, use quadratic formula, or I like to factor if at all possible. So I'm going to try and factor this polynomial. I use the box method for factoring. And in the box method for factoring, I create a little chart here where the first column are factors of 3 and the second column are factors of negative 56. So I need two numbers that multiply to 3. Well, that's pretty simple, 3 times 1. And now I need two numbers here that multiply to negative 56. So let's just find any two numbers. How about if I do negative 7 times 8, right? Those two numbers multiply to negative 56. But the key to making the box method work correctly is that when I cross multiply and add those two values up, I get the middle coefficient 2. So what I'm looking for is a positive 2. So if I cross multiply 3 times 8, that gives me 24. If I take 1 times negative 7, that gives me negative 7. And if I add those two, negative 7 and 24, that does not give me 2, does it? That gives me what, 17? So this box here is not going to work. So we need to scratch that and get a new box. Alrighty, so I'm going to keep 3 and 1 for my first column, but I need two numbers that multiply to negative 56. Let me see. Negative 56. Negative 56 is 8 times 7, I said. And we need a number that divides into 8. How about 4? 4 goes into 8. So 4 must go into 56. And in fact, 4 times 14 gives me 56. Let's try this combination of factors in the column. Let's put 14 here and 4 here. And remember now, when we cross multiply, we're cross multiplying, we have to get numbers so that the sum will give us 2 when we're done. 3 times 4 is 12. 1 times 4 is 14. And we remember that this is negative 56, so one of these two numbers had to be negative. If I make the bottom number negative, that gives me a negative 12, and 14 minus 12 gives me that number I'm looking for, 2. That means this box here will help me to factor this polynomial. 3x squared plus 2x minus 56 is simply factored as the following. 3x plus 14, which I get from the first row in my box, times 1x minus 4. We can re-multiply to check, and this quadratic equation has now been factored. At this point, I set each factor equal to 0 using the zero factor property. So we have 3x plus 14 equals 0. X minus 4 equals 0. And that gives us that 3x is negative 14, or x is negative 14 thirds, and x is 4. We have now solved the quadratic equation 3x squared plus 2x minus 56 equals 0. And again, if you can't factor, don't worry about it. Why don't you apply the quadratic formula? Or if you're daring, complete the square. You will arrive at the same two answers. All right, so let's not forget we're solving a word problem. So let's go back and answer the question. What are the dimensions, length and width of the rectangle? Well, in our problem, our width was represented by the variable of x. And we have two values for x. X is either negative 14/3 or 4. Now the width of a rectangle can't be a negative number, right? That wouldn't make any sense. So this is an extraneous solution. We can cross it off. 4, however, is a positive number and makes sense. This rectangle can certainly be 4 inches wide. So we say that our width is 4 inches. Our length? Well, that's determined by the expression 3x plus 2. And if our width is 4, then that means our length has to be 3 times 4 plus 2, right? Which is 12 plus 2, which is 14 inches. Therefore, the dimensions of our rectangle are 4 inches for the width and 11 inches for the length. And 14 inches for the length. You can finish by checking. Make sure that when you take 4 times 14, the length, times the width, you get 56, which you do. So our problem is complete.